All right, so we are almost done with the first week back. Okay, so things are going very well. We are going to be able to finish up the notes today. I'm going to give you your homework assignment. It's going to be due on Monday. Give you a little bit of time to go ahead and take a look at that. Don't forget, tomorrow morning is the deadline if you'd like to retake the exam from before the Thanksgiving break. I want to encourage a lot of people to go ahead and do that because this class was one of the three that had a failing average. There were several people who came in this morning to go ahead and take care of it, but you have one more day if that applies to you. Speaking of tests, next week on Friday the 7th is when you're going to have your second exam. It's going to cover all the information we've talked about when it comes to inverses, and it's also going to have some graphing information on there as well. The quiz we took yesterday where you graphed a sine or a cosine function, you're going to notice the exact same format, but you're going to have to graph a tangent, a cotangent, secant, or a cosecant. One of those four types will show up on there. Okay, so you want to be familiar and ready for that. I think that's all I have, unless anybody has any questions. Okay, let's get to it. We've been talking about inverses. We're on this packet right here. Now, when we're talking big picture, when I want to take the inverse of a function, we take the x's and the y's and we do something with them. We switch them. The x's become the y's and the y's become the x's. Now, this is our fourth day going over this topic. So, again, hopefully by now, these restrictions that we see on the front of your packet are starting to make a little more sense. Whatever you plug into an inverse trig function is a ratio. Okay, the sides of a triangle. The answer we're going to get is going to be an angle measure, whether it's in degrees or radians. And it depends on your calculator mode. We'll talk about that in just a second. But let's go ahead, kind of pull everything together. We've looked at sine inverse, cosine inverse, and we're pretty much finished with tangent inverse. Sine inverse, he's going to be restricted to quadrants 1 and 4. Okay, his answers have to fall between negative pi over 2 and pi over 2. Cosine inverse is going to be restricted to quadrants 1 and 2. He has to fall between 0 and pi. And tangent inverse is actually going to be in the same quadrants that sine inverse is. But what was the big difference between those? Christian says the pi over 2 is not included. That's exactly right. At pi over 2 and negative pi over 2, tangent is undefined. Remember, we can't divide by 0. So while sine inverse can include those boundaries, tangent inverse cannot. Now, if we're trying to figure out what quadrant we're in, how do we do that? We look at what about the ratio? Yeah, if it's positive or negative, and then we go to the corresponding quadrant. Okay, so let's see. Here's inverse cosine, did some problems. There was inverse tangent. Okay, now how far did we get yesterday? We finished B, so we haven't gotten C yet? Okay, so let's say tangent inverse of 0. All right, so let's go ahead and run through this, and then we'll do D, and then we'll go ahead and just finish up the rest of the notes. And you should have at least a little bit of time to go ahead and start on your assignment before you leave. I want to say that it's not a lot. First period got 10 minutes, I want to say. Then second period got about 13. They got a little more. Okay. So tangent inverse of 0. Okay, well, what quadrant would I put this in? There you go. Let's say we don't recognize it's a quadrantal just yet. Let's say, because 0 is neither positive nor negative. So let's say we just go ahead and try to create a triangle based on what I see here. Remember, tangent is always the opposite y over the adjacent x. Well, what would 0 be as a fraction? Yeah, 0 over 1. So from theta's perspective, we'd have the opposite 0 over the adjacent 1, right? But you notice you're ending up with a triangle that has a side length of 0, so that can't happen. If your diagram does this, that means, just like Christian said, it's got to be a quadrantal. Okay, well, let's kind of think about this. Let's look at the unit circle. Remember, tangent inverse, where's he restricted? He has to be 1 and 4, the right side of the unit circle, right? Between negative pi over 2 and pi over 2. Well, because of these two quadrants, that gives me 3 quadrantals that I could look at. So I have 0 radians, pi over 2, or negative pi over 2. Are there any of these that we can eliminate? Remember, what did we just say at the very beginning? it can't be pi over 2 or negative pi over 2. What's wrong with those? Yeah, remember, tangent's restriction doesn't include those boundaries. He's undefined there. So if I know it can't be those two, and these are the only quadrantals I have, well, tangent inverse of 0 has to be what? It's got to be 0. Okay. Because remember, think about it. Every time you evaluate an inverse trig function, your answer should be an angle. Every time you evaluate a trig function, your answer should be a ratio. And I'll remind you about that again. In fact, take a look at this. What's the ordered pair here at 0 radians on the unit circle? 1, 0. Remember, we're looking for the ordered pair where you take the y and divide by x. Well, 0 divided by 1 is 0. Because whatever you plug into the inverse function, that's a ratio, the sides of the triangle. Okay, well, let's try D. Tangent inverse of 5. Jane, what quadrant would I be in, 1 or 4? 1, because 5 is positive. Okay, so we always decide on the quadrant. In that quadrant, I'm going to draw a terminal side. Now what? Now, we are going to do the ratio, but let's go ahead and finish our triangle. And I just want to make sure, because I've seen some people connect it to the y-axis. Remember, we always connect it perpendicular to the x, not the y. So this reference angle here is what I'm looking for. Now, Christian said, okay, look at the ratio. Well, 5 as a fraction would just be 5 over 1, right? And we just previously saw that tangent is always y over x. So the opposite would be 5. The adjacent would be 1. And what would my hypotenuse be? No. And we can actually work this one out. Let's say we're looking for the radius. So the radius squared would equal 1 squared plus 5 squared. So the radius squared would equal 1 plus 25, 26. So square root of 26. Okay. Just easily use the Pythagorean theorem to help us out with that. Now, here's my question. Is this a special right triangle? Now, how do we know it's not 45, 45? Okay, those legs are not the same. How do we know it's not a 30, 60, 90? There you go. The hypotenuse should be double what the shorter side is. Okay, so absolutely not. Now, if this is the case, well, what do? I still want that angle theta, but I don't have a calculator. We have to use a protractor, okay? So this one I'm going to have to measure. Now, on your test next week, you do have several problems like this. And I'll go ahead and tell you, you are not going to have a calculator on the test next week. Okay, you're just going to have what you know and the protractor. So it's going to be okay. It's going to be okay. All right. So let me go ahead and kind of recreate this right here. We had 1, we had 5, square root of 26. Now, I always like to measure mine in centimeters. Again, if you want to use inches, that's perfectly fine. Now here, I can measure 1 and 5 centimeters exactly. I don't have to worry about converting. If I do need to, I convert it to millimeters to make it a little more exact. But let's start with this one. So I want 1. So let's say 1 is right about there. Would everybody agree? Okay. Now, vertically from that location, I want to go up 5 centimeters. Okay, so 1, 2, 3, 4, 5. Let's say right there. Would everybody agree? Okay. Put that little dot right there. Okay, now I'm going to go ahead and draw the sides of my triangle. So I'm going to draw this one straight up. This one just like this. Okay. And again, one little thing I always do is draw the sides beyond the vertex where they meet the intersection, because I really want to make sure my measure is as accurate as possible. Hey. Oh, hello. Thank you. Shane. Okay. Thank you. Here we go. Oh, just put it in the tracer. There you go. In fact, did anybody happen to go home last night and try this? Actually get the measure? Okay, Aiden, what did you get? 77 degrees? Okay. Well, let me go ahead and take my protractor. Let's see how close we're going to get. Oh, that is not what I'm going to do. Oh, I got a text message. Okay. All right, so again, some of the protractors are different. See, mine has crosshairs. Yours may not have a crosshair. It may just have a little open circle on there. But regardless, you're going to put that point on your origin. Okay, so let's see, right there. And what did you say, Aiden? You said 78? 77? Okay, so based on mine, I've got to use the inside arc. What would you guys say? I'd say maybe 78, maybe 79, somewhere around there. What would you like me to put? 79? Okay. Theta's about 79 degrees. Okay, and Aiden had gotten 77. So now let's actually plug it in the calculator and see how close we got. Okay, we're taking, and let's see here. Calculate, and I'm in degrees. Okay, so tangent inverse, it was 5, 78.6, so about 79. There we go. Okay, now here's my question. Let's say on the test next week we'd have had this problem. Aiden put 77. Okay, but I'm showing 79. Would she still get credit? Yes, absolutely. Remember, I'm going to go 5 above and 5 below. Okay, hopefully that should take care of any measurement errors we have. So good. Did anybody else get that? Okay, Dylan, good. Sure, a lot of people ran home and measured that with your protractor, right? Okay, there we go. All right. So let's move on. Let me go ahead and get rid of this. Get this ready for the next class. Okay. Now here's our last page, and then we are done with these notes. Okay, so I just want to kind of reemphasize a few ideas. It says use a calculator in radian mode to approximate the expression. Now my calculator is in degrees. We've already kind of talked about this problem. I can definitely go ahead and change it to radians, or if I know I'm in degrees, well, what can I do with my answer? I can just multiply by pi over 180. I can go ahead and convert it. Okay. Now I want to go ahead and just bring up some other ideas. When you're trying to evaluate cosine inverse or sine inverse, whatever you plug in, remember that's a ratio. So whatever triangle I happen to be talking about, sine is always opposite over the hypotenuse. So whatever the length of the opposite is over the hypotenuse, it should be giving me this negative 0.74. Okay. The answer from an inverse trig function is always going to be an angle measure. Okay, so we always want to keep that in mind, especially when we're looking at the compositions. But based on what we've done all week, can anybody just go ahead and tell me what quadrant would this be in if I were going to try to do it by hand? It'd be in quadrant 4. Why? Because it's a negative ratio, okay, a negative value. In fact, what do we know about my final answer? Should it be positive or negative? Should be negative. Remember, sine inverse and tangent inverse, if it's in quadrant 4, you have to rotate clockwise to get there. So I know no matter what, my answer is going to be negative. All right, so let me go ahead and do this. I'm going to show you very quickly how to plug this in the calculator. Now I'm going to change it to radians first, so go home. Now, if you wanted to actually change your mode, you'll go to settings from your home screen. Document settings, right here, the second tab. Change degrees to radians, and then I want to make that default. Okay, so now let's go in, sine inverse of negative 0.74. So my answer's got to be negative 0.83, because it won in 2 places, right? Okay. Now let's say, again, just like when I was speaking to Connor, you didn't change the mode on your calculator. In fact, let me go back. Okay, so I'm going to go back. I'm going to change this to degrees again. Again, always click make default. Okay. So now let's type in the exact same expression. See, because my calculator is in degrees, it's giving me my answer in degrees. All right. So you don't have to change the mode. If I just know that I want my answer in radians, I can just say times, control divide, and I multiply by what? Was it 180 over pi or pi over 180? Pi over 180. Okay. So I take my answer, I go ahead and multiply it, bam, I get the exact same answer as if my calculator was in radians. Okay. So that's the only thing you have to be very careful of. You have to know what mode your calculator is in. Okay, personally, I like to keep it in degrees and then just change it if I need to. Okay. All right, good. Well, can anybody tell me the next answer without even doing anything? Cosine inverse of 1.5. It's what? Undefined. How do we know that? There you go. Remember, whatever you plug in to an inverse trig function, that's a ratio. So this 1.5, he's a ratio of sides as well. But for cosine inverse and sine inverse, that ratio has to exist on a certain interval. It has to be between -1 and 1. Okay. So seeing that 1.5 does not belong to the interval is telling me already I shouldn't be able to get an answer from that. But let's say you didn't remember the interval and you just tried to go ahead and plug it in the calculator. Whether it's degrees or radians, if I say cosine inverse of 1.5, you're still going to run into that problem. The calculator's going to say we can't do that. Okay. Is everybody okay with that? All right. Now, let's take a look at this next one. Sine inverse of sine of 2.36 pi. Now, because this is our first composition, let's revisit the first page and see if we can figure out what the answer is going to be. Now, don't plug the answer in the calculator just yet. I want to show you that I can predict what the answer is going to be before we even plug it in the calculator. Okay? So we have sine inverse of sine. So I'm going to my front page here. So sine inverse of sine, I want this guy. Now, according to this property, what I input is going to be the answer if that value is between -pi/2 and pi/2. Okay, so let's come back over here. All right, this is only going to equal 2.36 pi if, okay, 2.36 pi is between -pi/2 and pi/2. Okay. Well, what do you think? Is this correct or is it not? Does 2.36 pi belong to that interval? It does not. I mean, think about pi/2, that's just 0.5 pi, right? So 2.36 pi is much larger, so he's not in the interval. Now, that doesn't mean we're not going to get an answer. Okay? I'm going to go ahead and predict that our answer, before we even get the decimal, has got to be 0.36 pi. Okay, so I'm looking at, and I've already seen some brows furrow a little bit, like, what? How do you get that? Let's kind of look at it graphically. 2.36 pi, what quadrant would that put me in? It put me in quadrant 1, right? If I start here in standard position and I rotate all the way around, how far have I gone? 2 pi. Now I just want to go an additional 0.36 pi. So this right here is 2.36 pi. But 0.36 pi, what's the word we use for that? Coterminal. They're coterminal, and the 0.36 pi fits with my restriction that I have here. So I'm going to go ahead and say that my answer is 0.36 pi. Now, I know you're saying, well, wait a minute, it wanted you to go ahead and plug it into 2 decimal places, right? Okay. Now, here I'm going to have to go back to radians, okay? Because is 2.36 pi radians or degrees? It's definitely radians. What tells you that? The fact that we have pi. Okay, so I'm going to document B out of here. Let's go back. I'm going to change it again. So degrees to radians. Whoop. Make default. Okay. Now, I believe it was sine inverse of sine of 2.36 pi. Okay. So here's my answer. But now, what did I say the answer was before I even did it? I said it was 0.36 pi. So if I go ahead and figure out what that approximation is, okay. So see, you can still get the answer. You don't necessarily. The only thing we needed the calculator for was to get the actual decimal value. We were able to get the answer without ever turning to the calculator. You just have to be familiar with those intervals. Okay. Now, I'll go ahead and tell you this. On the test next week, I said that I was not going to allow what? You're not going to be allowed a calculator. So, to make the playing field a little more level, these intervals, I am going to have those posted over on the back board. So you don't have to have them memorized. I would, definitely be familiar with them, okay? But they will be on the board during the test. So that's one less thing to worry about, right? Okay. Okay, let's go ahead and try the next one. I believe it's a tangent problem. All right. So we have tangent inverse of -4. Okay, well, it's a composition, so I would say let's look at the front of your nose. Tangent of tangent inverse. So I'm going to come back over here. Okay, so here's tangent of tangent inverse. Now it says whatever I plug in will be the answer if what? Yeah, well, let me ask you, is -4 a real number? Oh, just kidding. Yeah, there it is. That's exactly right. -4 is a real number. So just, again, knowing that, I don't have to do anything. I can say I know the answer is -4. Now, you got to be careful. What if it were tangent inverse of tangent? Could any real number be the answer? No, then you have a restriction. Again, it's on the front of your paper. Okay? And remember, those are going to be on the board to help you out. Okay. Let's look at the middle here, example 5. Now, both A and B, these are exactly like the problems we've been doing in the previous sections. Okay, we got a cosine inverse, we got a tangent inverse. So I don't think we need to do both of them unless you guys want to. Only first period wanted to do it so far. Let's do a poll. How many people want cosine inverse? How many people want tangent inverse? Okay, so let's take a look at B. And if anybody changes your mind, if anybody does want A, let me know. We can work it. So I want to evaluate tangent inverse of -√3. This is exactly how a problem could show up on your test. Okay. Well, first off, how do I decide what quadrant? Okay, it's negative, so that puts me in what quadrant? 4. So right there, because it's tangent inverse and I know I'm in quadrant 4, guaranteed my answer has to be what? I know the final answer has to be negative. Remember, because we rotate clockwise to get in there. We have to be within -π/2 and π/2. Okay, so I'm going to create my right triangle with the x-axis. There's the angle I'm looking for. All right. Let's see here. What was tangent's ratio again? Yeah, it's always the opposite y over the adjacent x. Well, what's -√3 as a fraction? Yeah, just put it over 1, right? So the opposite side should be the -√3, and then the adjacent side should just be the 1. So even if it's not a fraction, you can still make it a fraction. Okay. In fact, can anybody tell me what's the hypotenuse? Okay, it is 2. Okay, remember, don't forget to take the square root. Okay, does anybody want me to write that out? Just go through it to show you. Sure, okay. So let's say we're looking for that radius. So r squared equals 1 squared plus the -√3 squared. All right, so the radius squared would be 1 plus, what would that be? Just 3, because if you're squaring a square root, those are going to cancel. So r squared would equal 4, and then by taking the square root, that's where we get the 2 from. Okay. Now, here's my question. Is this a perfect, or I want to say perfect square triangle, a special right triangle? Yes. What is it, 45 or 30/60? 30/60. Now, here's the big question. If it's 30/60, you have to decide this angle that we're looking for, is he 30 or 60? He would have to be 60. Remember, 30 is always across from the shorter side. So I'm going to say my answer is either -60 or, what would that be in radians? -π/3. In fact, next week on the test, I'm going to ask if it's a special triangle, you go ahead and write your answer in radians. Okay. Now, what if this hadn't been a special triangle? Could I have still found the angle without the calculator? By doing what? There you go. Okay. Everybody loves protractors. Okay. Especially farmers. They're protractor. No? You'll laugh later. Okay. Actually, I just kind of thought of it. Yes. Oh, yeah, well, yes, of course. All my jokes are, I'll say decent. I won't say amazingly good. For this won't erase for some reason. Okay. There we go. Okay, let's take a look at C. So cosine inverse of cosine of negative 1.1. Okay, so we have another composition of functions involving an inverse, so I'm going to go back over here to the front page. Remember, it's cosine inverse of cosine. Okay, so now I want this guy right here. Now, whatever I input, the x, he's the answer only if he belongs to 0 to pi. So let me come back over here. Let's talk about a couple things. Okay, so this one, only if he belongs to 0 to pi. All right. Well, remember, what would that negative 1.1 represent? Is he a ratio or an angle measure? Okay, how many people think he's a ratio? How many people think he's an angle measure? Ooh, a lot of people didn't vote. He is a angle. Because this isn't cosine inverse, it's cosine. The only thing you ever plug into a trig function is an angle. The only thing you ever plug into an inverse trig function is a ratio. Okay? So let's see, can I say that my answer is negative 1.1? Well, knowing this is an angle, I can compare them to pi, right? So is negative 1.1 between 0 and pi? No, it's not, because what's pi? 3.14. Now again, just like this one over here, that doesn't mean we're not going to get an answer. It just means that the answer is not exactly negative 1.1. Now this one, it revolves around an identity that I have not yet shown you. Next week, I'm going to introduce you to identities for the trig functions, and I've mentioned that briefly, but I'm going to go ahead and show you the one here. I'm not going to prove it today, but I'm going to go ahead and talk through it. Is cosine even or odd? Think back to when we graphed him. Okay, he is even. That means I can fold along what axis? The y-axis, and the two parts come together perfectly, right? If you think back to the first 6 weeks when we introduced even and odd functions, we had this definition. If you can take any function and plug in negative x, if I can get the original function, okay, then it was going to guaranteed to be even. Like x squared is definitely an even function, right? Well, what you're going to find is that if I do the same thing for cosine, if I take cosine of negative theta, well, that's exactly the same as cosine of theta because he's an even function. Okay. So I can actually use that to apply to this problem right here. Now, I didn't give you one like this on the homework, but I thought it was just interesting to go ahead and bring up. So cosine of negative 1.1, well, that's actually cosine of what? 1.1, right? If I just apply the even identity property. Okay. Now, does 1.1 belong to this interval? Yes. So that, whoop, now we're negative. That's my answer. Okay. Now, if you're a little hesitant on that one, that's okay. I just wanted to go ahead and bring it up. It's kind of foreshadowing one of the identities that we're going to be looking at. But you do not have one like that on the homework. There's not one like that on the test. Okay. All right. Here are our last problems. Okay, exact values graphically. Again, we are not using a calculator to do this, but I want to reinforce an idea here. Okay. When you evaluate a trig function, and I'm just going to use sine, doesn't matter which one you have, what do you plug in? An angle or a ratio? An angle. You only plug angles into a trig function. Now, the answer is going to be a what? The answer is going to be a ratio. Now, when you're dealing with an inverse trig function, what do you plug in? You plug in a ratio, and the answer is going to be the angle. It's real easy to confuse those, but it's very important we know the difference. You only plug an angle into a trig function. You only plug ratios into an inverse trig function. Okay, so with that in mind, let's take a look at these. Cosine of sine inverse of negative 1/2. Okay, cosine of sine inverse of negative 1/2. Well, we always start from the inside function, and we're going to work out. So forget about this cosine right here. Imagine, it's just like the problems we've been looking at this week. Sine inverse of negative 1/2. Okay, first, what quadrant would that be in? 1 or 2, or 1 or 4, excuse me. 4, why? Because it's negative. Okay, and you can tell we're kind of highlighting quadrant 4 here, but also. So I'm going to go ahead and draw my terminal side, create a right triangle. So this is what I'm looking for. Okay. Now remember, sine is what over what? It's always y over r. So I know that the opposite should be the 1. The radius should be 2. And remember, the radius is never, never negative. So the 1 has to have the negative. What's the x value? Okay, it's got to be root 3, right? Okay. All right. Now, does anybody want me to run through the Pythagorean theorem? Okay, no. Now, here's the thing. This one actually works out nicely. What would theta have to be?
30.
It's got to be 30. This is a 30, 60, 90. 30 is always across from the smallest side. But here's the thing. We don't actually need to know that angle in order to answer the problem. When you evaluate a sine inverse, the answer you're going to get is an angle, right? So what happens if I evaluate cosine of an angle? Am I going to get an angle or am I going to get a ratio? I'm going to get a ratio. So I'm going to use this one right here, even though I know it's 30. That makes no difference. Cosine is always adjacent over hypotenuse. So I know that the answer here has to be square root of 3 over 2. Because your outside function is a cosine, it's not an inverse, the final answer has to be a ratio. Okay. Does that make sense? Okay. Now, whether or not you know what that angle is kind of irrelevant. You don't need to know it. All right. So let's try another one. Sine of cosine inverse of 5/13. Okay, so forget about the sine. Put the sine out of your mind right now. Okay. Miriam, what quadrant would I draw my triangle in? The first, because 5/13 is positive. And, it looks like we're looking at a very large quadrant 1 here. Okay. So here's theta. All right. Now, cosine is always adjacent over the hypotenuse, right? So I'm going to say this is 5/13. Okay. Well, hopefully you'll recognize this as a triple. 5, 12, 13. Now, even if you didn't recognize that, again, Pythagorean theorem is going to get you that number. Okay. Now, is this a 45, 45, 90? It's not. Is it a 30, 60, 90? It is definitely not. So the only way we're going to be able to figure out this angle is if I measure it with my protractor, right? But again, we don't need to know the angle. Okay. We know that cosine inverse of 5/13 is going to give me an angle, but we already have the triangle created. So what's the sine of theta? Remember, sine is always what over what? 12/13. Because whatever theta turns out to be, my answer is still going to be a ratio. Okay. Now, you want to be careful. What if we'd done it the other way? What if I'd given you something like cosine inverse of sine of x? Would my final answer be a ratio or an angle measure? It would be an angle measure because the outside function is an inverse. Okay, so like I said, it's real easy to confuse those, but it's very, very important that we know the difference. Okay, last thing. We are done with the notes, and I know what you're saying. Wait, Mr. West, we got this problem right here that we really, really want to work because it's a word problem, and we love word problems. Okay, I know, I hear you. Okay, but we're going to do something different this time. I came in early this morning and I recorded myself talking through this problem the entire process, all the way to the answer. So not only did I walk through the problem, help you get the answer, but here is an additional problem that's not in your notes that you can go ahead and practice on. Okay, I'll go ahead and tell you, I put a problem exactly like these on your test. Okay, so here's where each person's going to have to make a decision. Sometime between now and next Friday, you're going to need to go to the website, watch the video, follow through, and practice this. Okay, because you have one of these on your test, right? Now, you could absolutely decide not to do that, but you're kind of saying that I'm going to forfeit those points on the test. Okay, because I'm guaranteeing you I've already put one on there just like this. Okay, and for some people, we really need to make sure this test grade is going to be as high as possible because we're very, very close to the end of the semester. We are about to finalize grades. Okay, so please, please, I'm telling you, between now and next Friday, you need to go to that website. You need to watch this video. It's less than 10 minutes. Okay, it is not going to take up a lot of your time. All right, questions on that? Okay, let's go ahead and pass out the homework. Okay, Miss Stern is taking care of that for me. The homework is going to be due on Monday. Okay, so tomorrow we'll go ahead and start the next lesson, and we'll see how far we get. Okay, I'm going to cancel that.